Okay, I'm going to go ahead and go through the Unit 5 test review that's on paper. So first thing we're going to do is look at these graphs that we're given. So we're given this first graph. First off, we notice that because it's flipped upside down, then we have this negative out front. So very first thing, we have our vertex. Our vertex is always at the very top or the very bottom of the graph. So our vertex here is going to be -1, comma 9. It's always written as an ordered pair. Our axis of symmetry goes straight down the vertex. It's a vertical line, so we write it as x equals x value of the vertex. Domain is always -infinity to +infinity for a quadratic. And then range, we start all the way at the bottom from -infinity, and it goes up and it stops at 9. So we would go to 9. Make sure to include a square bracket on that because that 9 is included. X-intercepts are going to be where we cross the x-axis. So we cross in two spots. We cross at -4, 0, and we cross at 2, 0. Little side note, if I wanted to list the roots to this graph, it would be the same thing as our x-intercepts, but we would write them in those curly brackets. All right, y-intercept is where we cross the y-axis, so that's going to happen at 8, so 0, 8. Absolute max or min should always be your vertex, and it's only going to be one or the other. So here, since our graph is going up and then back down, we're going to have an absolute maximum at our vertex. So that maximum is going to be the y value at x equals -1. The absolute minimum, we would just put none. And then for end behavior, because both ends are going down, they should always be going the same direction on a quadratic, and it's going towards -infinity for both of them. All right, so I saved increasing and decreasing for last because I feel like this is where a lot of people struggle. So I already kind of went ahead and color coded it, but remember that our vertex cuts our quadratic graph in half. So we have this x equals -1. That's always going to be the number that is in our increasing and decreasing interval. So this left half of our graph, if we were to trace it, we're tracing it up. So that means that from -infinity on our x-axis to that axis of symmetry, so -1 is the x value, our graph is increasing. But then at -1, it starts decreasing, and it decreases until +infinity on the x-axis. Okay, I'm going to go a little quicker now because we already did one example. So axis of symmetry, straight down the middle, so it would be x equals 3. Our vertex would be 3, 0. Domain, again, will always be -infinity, +infinity for a quadratic. Range, now we have a hard bracket first on 0, because that's the lowest y value, and it goes until infinity. X-intercepts, we only have one, and it crosses at 3, 0. Y-intercept, we cross at 0, 9. Increasing, so this time our right half of our graph is increasing. So from 3 to infinity, our graph is increasing. Remember, this number right here should always be the x value of your vertex. And then decreasing would be the opposite side, so -infinity to 3. Absolute max, we have none. Absolute minimum would be 0 at x equals 3. End behavior, both ends are going up, so we have infinity, infinity. All right, axis of symmetry for this next one. Straight down the middle, x is going to equal -1. The vertex be -1, -3. Domain should hopefully be an easy one. -infinity to +infinity. Range, we're going to have -infinity to -3. Hard bracket on that -3. X-intercepts. If you notice this, our graph does not touch the x-axis at all, so we have no x-intercepts. Y-intercept, we do cross at 0, -5. Increasing is going to be the left half of our graph this time, so from -infinity to the x value of our vertex, which is -1, and then the other half is decreasing. This time we have an absolute maximum, so we'll have a maximum of -3 at x equals -1. Absolute minimum is none. And then end behavior. Both of our ends are going down, so they're both going to -infinity. All right, so if we're looking at number 4 on the next page, it asks us for the end behavior, and all we're given is an equation. So the thing that's going to tell us about end behavior is the sign. Oh, kind of just erased it. The sign in front of our a value. So if a is negative, and remember a is always in front of the x squared, if a is negative, then both ends are going down. So both ends are going to be going to -infinity. All right, so number 5, so this is where we start solving. So this is like the meat of the test. So what are the intercepts of the function? So this means that we're going to solve by factoring. So I'm going to go ahead and set this up. So we have 10x squared minus 11x minus 6 equals 0. And what we're going to do is first multiply the 10 and the 6, so that would be -60, and figure out what multiplies to -60 and adds to -11. So in this case, we could try a couple things, like we could try 6 and 10, which wouldn't work. We could try 5 and 12, which wouldn't work. But what will work is 15 and 4. So we would have to make, because we want a -11, we'd have to make the 15 negative. So we're going to go ahead and replace that middle term with those two numbers we just found. And then we're going to do our factoring by grouping. So group these first two terms together. The first two terms, the GCF would be 5x. We have x, nope. We would have 2x minus 3. And then the GCF for the second two would be just 2. And we'd have 2x minus 3. All right, I'm coming up over here now. So we have our two factors. We have 5x plus 2 equals 0. And we have 2x minus 3 equals 0. So then we're just going to solve. I'm going to just erase my parentheses so I don't have to deal with that. And what we're going to do is get x by itself. So we have 5x. We're going to subtract 2 from both sides. 5x equals -2. Divide both sides by 5, and we get x equals -2 over 5. So that's one solution. And then our other one, we solve this one, so we're going to add 3 to both sides. We have 2x equals 3. and then divide both sides by 2, we get x equals 3 over 2. So those are our x-intercepts. So remember, solutions, x-intercepts, roots, and zeros, they all mean the same thing. Okay, so completing the square, I think, is where a lot of people struggle. It is completely different than what we normally have done, so it's pretty much the only thing in this unit that's brand new. So let's go ahead. So first thing we should do, we have a is 1 here, so that means we have the easier case for number 6. So I'm going to go ahead and split up my first two terms, get to stay inside, and then my third term, that plus 32, has to be lonely on the outside. And remember, when we're setting this up, we always have a plus on the inside and a minus on the outside. So what we're going to do now is figure out what number goes here and what number goes here. So first thing we need to do is worry about this 12. So we're going to take 12, divide it by 2, which equals 6. Once we do that, we're going to square that number, and we should get 36. So we're going to have 36 here. And because we don't have a number out front, we just have 1, then we're also going to have 36 on the outside. All right, so now we need to factor what's in the parentheses here. So this should always be a perfect square trinomial. So this will be x plus 6 squared. Remember that this sign should always match this sign. And then we have 32 minus 36 on the outside, so that'd be minus 4 equals 0. All right, so we are not done yet. Now we need to solve for x. So what we're going to do is add 4 to both sides first. So we get x plus 6 squared equals 4. Then to get rid of the squared, we take the square root of both sides. And don't forget, when you do that, you have to put a plus or minus out front. So that square root cancels that out. And we have x plus 6 equals plus or minus, and the square root of 4 is just going to be 2. All right, so I'm coming up over here, and we now subtract 6 from both sides. So we have x equals negative 6 plus or minus 2. So since those are both really pretty numbers, we're going to break it up. We're going to figure out what negative 6 plus 2 is, and negative 6 minus 2. So negative 6 plus 2 would be negative 4, and negative 6 minus 2 would be negative 8. And those would be your two solutions. All right, let's go ahead and do number 7. So number 7 is now we have a 2 in front of our x squared. So this is where we have like one extra step that we need to worry about. Remember, these first two terms get grouped together. They're stuck together, but then the 12, that last term, always gets left behind. So first thing I want to do is figure out what I can divide both this 2 and this 8 by. So in this case, our GCF would be 2. X squared minus 4x, and we always plus on the inside blank, and then carry that plus 12 down, minus on the outside blank. All right, so we're gonna worry about this blank first. So it's the same thing we did before. We take this middle term, so we do 4 divided by 2 equals 2, square it, and that equals 4. So we're gonna have 4 on the inside. But because of this 2 we have on the outside, we have to multiply the 4 by the 2 before filling it in this blank. So 4 times 2 is 8. So we'll put 8 there. All right, now let's simplify this whole thing. So we have a 2 on the outside. And if we factor that, we're going to have x minus 2 squared. Remember again that this sign and this sign should always match. And then it would be plus 4 equals 0. All right, so let's go ahead and solve this. So now we're going to have 2x minus 2 squared equals negative 4. We subtract 4 from both sides. Now divide both sides by 2, and we get negative 2. Take the square root of both sides. Don't forget your plus or minus. Those are going to cancel, and we get x minus 2 equals plus or minus. Let's go ahead and simplify this one. So we have negative 2 under the square root. So I'm going to break that up to be negative 1 and 2. We can't do anything with the square root of 2, so that just is going to have to stay in our problem. But the square root of negative 1 is going to be I. So we'd have I square root of 2. And then our final step, so x equals, we add 2 to both sides. So we'd have 2 plus or minus I square root 2. And that would be your final imaginary answer. Okay, so now what we're going to do is we are going to switch this function to vertex form. So we already have it in standard form. Standard form is when we have ax squared plus bx plus c. So the way that we switch it from from standard to vertex form is simply by completing the square. So first thing I'm going to do is group my first two terms together and look for just the numerical GCF. So I'm going to have just a negative on the outside. And we're going to have x squared minus 6x plus blank. That minus 5 stays on the outside, minus blank. All right, so we're going to follow the same steps we did before. So for this number, we're going to do negative 6 divided by 2, which would be negative 3, squared equals 9. So we're going to have plus 9. All right, so now we just have a negative on the outside, so we have to do 9 times negative 1, which is going to give us negative 9. So on this problem, we have a double negative, so this is going to end up simplifying to be, we have x minus 3 squared. These both become positive, so negative 5 plus 9 would be plus 4 equals 0. Nope, sorry, we don't need the equals 0 for this. We're just writing it in that form, so that's all we had to do. All right, and now we need to list out the transformations that we have. So this first transformation, this negative on the outside, that is going to be reflecting over x-axis. This one right here, that minus 3, is going to move us to the right 3. Remember, everything on the inside is opposite, so that minus makes us move to the right. And then this plus 4 is going to move us up 4. Okay? And then we can go ahead and sketch a graph. So we have these transformations, so I'm going to go ahead and move us to the right 3 and up 4. And since we don't have any stretch or shrink, we're going to go down 1 over 1 because of the negative in front. And then if you think about our perfect squares, the next perfect square is going to be 4. So if we go down 1, 2, 3, 4 over 2, and this is something that you won't need to know for your test, but it is helpful for this question. So you can do number 9 by factoring, or since we have the graph up here, we can go ahead and use the graph. So I'm going to go ahead and just say that where we cross the x-axis are our solutions. So 1 and 5. Okay, so let's go ahead and go to the next page. So now we are going to draw this graph just like we did on the other page. And this is, again, you won't have to necessarily graph like this many points, but it's helpful. So the way that this is going to work is think about your parent function. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So let's just use that when we're worrying about it. So keep that in your head, and we're going to look at this equation that we're given. So we moved, because of that plus 1 on the inside, we moved to the left 1, and we moved down 9. So that gives us our vertex. So if we move left 1, down 9, then we're going to have a point right there. And so this is always our vertex. So now let's go up 1 over 1. So that's our next point in both directions, up 1 over 1. For our next point, we're going to go over 2, up 4. Over 2, up 4. And then our last point that we need is going to be over 3, up 9, which is all the way to the x-axis. And again, like I said, you will not have to do this on your test, but it is good practice. All right, so we are now going to use this graph that we found, and we're going to answer some true-false questions. So negative 2, 0 is an x-intercept on this function. So negative 2, 0 happens right here. So this would have to be false because our graph doesn't even cross through that point. For B, 0, negative 8 is the y-intercept. That is right here. That is where our graph crosses the y-axis, so that would be true. This function has 2 x-intercepts. That is also true because we cross here and we cross here, so we would say true. The absolute minimum of this function is negative 9. So the lowest y value we go to is going to be negative 9, so we would say true. This question doesn't have the part where we say at x equals negative 1, but that doesn't make it false. All right, end behavior as x approaches infinity. So let's look at our graph. As x approaches infinity, so that's this direction. Nope, sorry, read it wrong. As x approaches negative infinity, so that's this side, negative infinity, our graph is going up. Our graph is going up on both sides. So since we have this positive infinity, this would be true. Same thing over here. As x goes to positive infinity, our graph is going up. So that means this would also be true. The absolute minimum of this function is negative 1. So we know this is false because we already touched base with that on D, but we always talk about our absolute minimum being our y value. So negative 1 would be the x value of the vertex, so that would not work. For H, it is increasing on the interval negative 9 to infinity. So let's see, negative 9. So remember, this is kind of like a trick. So -9 to infinity, that like darkened it too much. -9 is going to be the y value of our vertex, but we always want our increasing, decreasing to be x value. So it's not the x value of the vertex, so this would be false. But first thing for I, -1 is the x value of the vertex. And so let's check if it's decreasing on that interval. So from -infinity to -1, our graph is going down. So this would be true. The function is shifted to the right one. We already figured that part out here. So we would say false. Okay. So next questions are solving by factoring. So this first question is going to be a difference of squares. So remember, we take the square root of both of these, and we always have our two sets of parentheses. Square root of 36 is 6. Square root of 25 is 5. And then we always do plus, minus. All right, we set them both equal to 0. We'd have 6x equals -5, just by subtracting 5 from both sides. And then divide both sides by 6. So we get x equals -5 over 6. All right, 6x equals 5. X should equal 5 over 6. So our two solutions, our two roots, are going to be -5 over 6, 5 over 6. All right, for number 13, this one is another one where we're factoring and our first term is not 1. So we're going to go ahead and multiply 8 to -3, which would be -24. And we need to figure out what's going to multiply to -24 and add to 12. So this would be 12 and 2. And because we want that 10 to be positive, we would make the 2 negative. So I'm going to go ahead and replace that middle term with the 12x and the 2x. And then we're going to group the first two together. So the GCF for that would be 4x. We'd have 2x plus 3 left inside. And then our GCF for the second two would be -1. So we'd have 2x plus 3 left inside. So now we just take both of our factors, which would be 4x minus 1, and set it equal to 0. And then 2x plus 3 equals 0. So again, getting x by itself, we'd add 1 to both sides, divide both sides by 4, so we get x equals 1/4. And then we would subtract 3 from both sides, and then we would divide both sides by 2. All right, so our two solutions would be -3 over 2 and 1/4. Okay, let's keep going. So if we're looking at number 14, all we have to do when we have a graph and it asks for the solutions is look where it crosses the x-axis. So it crosses in two spots. It crosses at -5 and it crosses at -1. And that is it for number 14. So whenever you have a graph, just look where it crosses. All right, we've done quite a few of the next two, so like 15 and 16. So I'm going to go kind of quick through the foiling part, but the setting up part is kind of the most important part. So when you're given your two roots, remember when first thing we want to do in order to write it in standard form is to first write it in factored form. So if we have positive 4 and positive 7, we're going to switch those signs. So they're not going to be positive anymore, they're going to be negative. And so what we're going to do now is FOIL everything out. So we're going to multiply the first terms together and get x squared. The outside terms would be negative 7x. The inside terms would be negative 4x. And the last two terms, negative 4 times negative 7, would be plus 28. Combine your like terms, which are the two middle terms. So we'd have x squared minus 11x plus 28. And because it asked for it in standard form, add a y equals, and then you're all done. All right, roots are fractions now. So this, we're going to write it as a fraction first. 1/2, 2/3. All right, so let's switch the sign. So 1/2 was positive, so let's make it negative. 2/3 was negative, let's make it positive. So what we want to do is take this denominator and swing it up in front of the x. And same thing over here, we're going to take the denominator of 3, swing it up in front of the x. And then we FOIL. So we're going to multiply the first terms together. So that would be 6x squared. Multiply the outside terms, which would be 4x. Multiply the inside terms, which would be negative 3x. And multiply the last terms, which would be negative 2. So we would end up with 6x squared plus x minus 2, and y equals that. And the x came from 4x minus 3x, which equals x. All right. Solve the following equations. So this is where we can solve these without any of the methods we have. Let's just get x by itself. So first thing I'm going to do is subtract 40 from both sides. So x squared equals negative 40. And then we're going to take the square root of both sides, add that plus or minus. We'll have x equals, and we're going to go ahead and simplify square root of negative 40. So I always want to pull that negative 1 out first. So if your square root's ever negative, let's do that first. And then let's figure out what we can divide 40 by. So what perfect square? I like to start with the lowest one first. So our lowest perfect square, yes, 1 is a perfect square, but that's not really going to do much for us. Next is 4. 40 divided by 4 is 10. So that one works out for us. So the square root of negative 1, well, first the square root of, or sorry, let's put our plus or minus first. So we have plus or minus. Square root of negative 1 is I. Square root of 4 is 2. And square root of 10, we can't simplify it all, so it would just be square root of 10. So that would be your final answer. All right, next one, let's do the same thing. So we could technically factor out a GCF of this, but let's just go ahead and isolate it. So negative 4x squared, let's add 36 to both sides. Divide both sides by negative 4. So we get x squared equals negative 9. Take the square root of both sides. Don't forget your plus or minus. And we'd end up with x equals, and now we got to simplify. So square root of -1, and then the square root of 9 is a perfect square, so we don't really have to do much work for this, especially if you know your perfect squares. So we have plus or minus square root of -1 is I, and square root of 9 is 3. So we'd have 3I. That would be our final answer. All right, number 19. So this is where we want to find the discriminant. Remember, the discriminant is b squared minus 4ac. So on your test, you will be given the quadratic formula, but I'm not going to tell you what the discriminant is. So it's up to you to remember this. So if you're making your note card, I would suggest putting that your discriminant is b squared minus 4ac. So let's go ahead and figure out what a, b, and c are first before we start. So we have these three. A is always what's in front of the x squared, so that would be 7. B is what's in front of the x, so -8. Make sure you take the sign with it. And then C is our last term, which would be 1. So let's plug it into the discriminant. So our discriminant equals b squared, so -8 squared. Be very careful about this. The b is negative, but when you square it, it will be positive. So make sure you put parentheses around the -8. Minus 4 times a, which is 7, times c, which is 1. So you could type that whole thing into a calculator or break it up into pieces. We know the square root of 8 is 64. And then 4 times 7 times 1 is 28. And if we subtract those two, we get 36. All right, so our discriminant is 36. And now what we need to do is decide, so we have a positive perfect square. So that's one of our that's one of our determinants. Positive perfect square. That means that we have two real rational zeros. So again, this, I'd say, listing out all the different types of determinant, putting that on your note card may be helpful for the test. All right, next one. So next one, we have a bunch of questions where it asks us for the discriminant, and we have to say the type of solutions, and we have to solve using the best method. So based on the discriminant, that tells us what our best method would be. So first thing, let's find the discriminant. So let's see, we've got A, B, and C. So B squared would be 8 squared, which is 64, minus 4 times A times C. So that would be 64 minus 96, which would be -32. So our discriminant is -32. Now, based on that, because of the negative, that tells us that we're going to have two imaginary solutions. And whenever we have imaginary solutions, our best methods are going to be completing the square or the quadratic formula. So either of those are acceptable, but what I like to do, because we've already found the discriminant, I think it is way less work, it's way easier to go ahead and use the quadratic formula. So we have the quadratic formula up here in your box, and remember that the quadratic formula is going to be given to you on the test. So let's go ahead and plug the rest of it in. So remember, our discriminant is what's under the square root. We already solved for that. So let's go ahead and write out x equals negative b, so -8 plus or minus the square root of negative 32, that's what we got for the discriminant, over 2 times a, which would be 2 times 4, which would be 8. Okay, so now what we have to do is simplify. So I'm going to go ahead and try to simplify my square root. So I'm going to pull the negative out. That should be our first step if it's negative. And then let's figure out what's the biggest perfect square we could divide 32 by. So yes, we can divide 32 by 4, but there is a bigger perfect square that we can divide it by. So let's do the biggest possible. So in this case, it would be 16. And if we divide 32 by 16, we'd be left with 2. All right, so what we're going to do is simplify that. So let's get square root of negative 1 is I, square root of 16 is 4, and square root of 2 is going to stay. So we're going to end up with negative 8 plus or minus 4i square root 2. So we're just writing all that out in place of the negative 32 and over 8. Okay, so our last step with this is going to be deciding if we can simplify anymore. So we can only ever simplify anything on the outside. That 2, because it's under a square root, you cannot touch it. So what we're going to do, because we have 8, 4, and 8, we can divide all of those numbers by 4. So let's do that. So negative 8 divided by 4 is negative 2, plus or minus 4 divided by 4. We're just going to be left with 1. We don't have to write the 1, especially because we have an I out there. Remember that 2, we can't touch it, just stays the same. And then 8 divided by 4 is 2. So that would be our final answer. And I'm just going to draw an arrow so we don't have to rewrite that. All right, so number 21. So let's find our discriminant, but first thing, we need to make sure that we're set equal to 0. So we have this 4x over here. I'm going to subtract 4x from both sides. I'm going to rewrite this so we have x squared minus 4x minus 3. So it's still in the same order that we're used to. So let's find the discriminant. So d equals b squared. So b in this case is negative 4. So negative 4 squared is 16 minus 4 times a. There's nothing in front of the x squared, so it's 1. And negative 3. Don't forget to take that sign with you. So this would be 16 plus 12, which would be 28. So our discriminant is positive, but 28 is not a perfect square, so we're going to have 2 irrational solutions. That means our best methods would be completing the square or the quadratic formula. Again, for this, especially when you have to find the discriminant first, I suggest you use the quadratic formula. So that's what we're going to do. So I'm going to go ahead and do x equals negative b. Our b value is already negative 4, so we're going to have a double negative there. Plus or minus the square root of 28, that discriminant we already found, over 2 times a. A is just 1 in this case, so it's just going to be a 2 on the bottom. All right, so this is going to be the double negative up here makes that a positive 4, plus or minus. And then let's simplify our radical. So square root of 28. Let's break it up into the perfect square and the not perfect square. So what would the biggest perfect square we could divide 28 by be? In this case, it would be 4, and we'd be left with 7. So 28 divided by 4 is 7. So we have the square root of 4, which is 2, and the square root of 7 just stays square root of 7. That's what we're going to put for the square root of 28, all over 2. All right, and then we just simplify the numbers if we can. So we've got 4, 2, 2. We can divide all of those numbers by 2. So 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, so we just have square root 7. And then we would have nothing left on the bottom, so this would be our final answer. All right, next one, let's find our discriminant. So A, B, C. So B is -1, so -1 squared minus 4 times A is 1, C is 2. So that would be 1 minus 8. 1 minus 8 gives us -7 for our discriminant. If it's negative, then we're going to have two imaginary solutions. And the best methods would be completing the square or the quadratic formula. Like I said before, quadratic formula is way easier in this case, so I'm going to go ahead and do the quadratic formula. So we're going to plug it in to be x equals -b, which would be -1, plus or minus the square root of our discriminant, which would be -7, all over 2 times a, which would be 2 times 1. All right, so let's simplify the square root. This would be square root of -1. 7 can't be divided by anything, so it would just stay that. And now we just write out our simpler fraction. This becomes +1 plus or minus square root of -1 is I square root 7 over 2. And that would be our solution. So we're done there because 1, because there's a 1 in front of the I, and 2 can't be divided by all the same number. So that's as simple as it gets. All right, number 23. So we have to make sure it's set equal to 0 first. So we have 5x squared. We're going to subtract 10x, add 5. So minus 10x plus 5 equals 0. Our discriminant, b is -10, so -10 squared minus 4 times a is 5 and c is also 5. So in this case, we'd end up with 100 minus 100. 100 minus 100 is 0. So that means that we are going to have one real rational solution. And whenever that's the case, whenever we're going to have a rational solution, best method would be to factor. So let's look at what we have. We have 5x squared minus 10x plus 5 equals 0. And now we can factor out a GCF of 5. X squared minus 2x plus 1 equals 0. So let's factor what's inside the parentheses. So what will multiply to 1 and add to -2? In this case, it would be x minus 1, x minus 1. And because they're the same, and once we set it equal to 0, the GCF doesn't matter when we set it equal to 0. So all we have to do is just set one of those equal to 0 and then solve for x. So x would equal 1. And that's the only solution that we have, one real rational solution. All right, number 24. Now we're going to, do the exact same thing. Discriminant equals b, in this case, is 1. So we'd have 1 squared minus 4 times a is also 1. And c is negative 12. So that would be 1 plus 48. 1 plus 48 is 49. So our discriminant is a positive perfect square. So the type of solution we would have is 2 real rational. And the best method is going to be to factor. So we're going to go ahead and factor, figure out what multiplies to negative 12 and adds to 1. That would be 4 and negative 3. So we'd have x plus 4, x minus 3. And then set those both equal to 0. We'd have x equals negative 4, x equals 3. Alrighty, last one on this page, and we only have 2 more. So our discriminant in this case, so we have x squared plus 0x. There's no x term, so b would be 0 minus 49. So when we do our discriminant, 0 squared is 0, minus 4 times a is 1, and b is negative 49. So that ends up being positive 196. 196 is also a positive perfect square. So that means we would have 2 real roots. And the best method would be to factor. And you can kind of look at number 25 and notice that because it's a difference of squares. So x squared minus 49, we can just factor as x plus 7, x minus 7 equals 0. Set them both equal to 0, so this one would equal negative 7, and this one would equal positive 7. So our two solutions are negative 7, positive 7. Oof. All right, so now the last two are going to be our application problems. So these are ones where you would have Desmos to solve these, but you do have to know how to solve these. So what we're going to do first is read through the problem and figure out what's important. So we have the height in h feet above the ground level reached by a ball, t seconds from when it is thrown, is given by this equation. So first thing we want to do, let's just type this equation into Desmos, but remember you have to use x instead of t because t isn't going to work. So once you type that in, we should have a quadratic, an upside down quadratic. And it's asking us how long does it take the ball to reach its max height? Maximum will always mean look at the vertex. Okay, so let's look at the vertex and decide how to answer these two questions. So it asks what or how long it takes blank seconds to reach. So it says how long does it take for the ball to reach its max height? So it takes blank seconds to reach, and the max height blank feet. Okay, so let's kind of like fill those blanks in. So our vertex on this problem is 221. And we get that from looking at the graph on Desmos. So t seconds, this is t, this is h. So it takes 2 seconds to reach 21 feet, which is its maximum. Okay, so whenever you see max, you should think vertex. All right, last question. The height is h meters above ground level, reached by a stone, t seconds from when it is thrown. For how long is the stone in flight? So how long time. So we know how long means that we're going to be in time. And it's going to be seconds again. So it will be blank seconds. So we need to type this into Desmos also. Again, don't forget to switch it to X because you will not get anything that works for you if it's a T. And this time it doesn't ask us anything about a maximum or minimum. So we're definitely not looking at the vertex. It's asking us how long we are in the air. So if we think about this little sketch of this graph we have, this point right here, that is going to be when the stone hits the ground, when the height is 0. So our height is 0. What is or how long does it take to get back to 0? So on this graph, that happens at 4, 0. So it takes 4 seconds to hit the ground, or it's in flight for 4 seconds. All right, so make sure that you turn this in when you come in on Friday and make sure to prepare your note card. So I gave you some tips on what you should have on your note card. Also, you can come in early on Friday if you need help. You can also go to Homework Club on Thursday, and Miss Colville will be there to help if you have any questions. Alrighty, y'all enjoy the rest of your day.